Welcome back to this tutorial series. In this tutorial, entitled Create Calculation Views and Expose Them via the SAP Cloud Application Programming Model with SAP HANA Cloud. In this tutorial, we're going to learn how to combine HANA Native Artifacts like calculation views with SAP Cloud Application Programming Model. We're going to learn the basics of creating HANA Native Artifacts when you're working within an SAP Cloud Application Programming Model project. We're going to learn how to create HANA calculation views in general, and we're going to learn how you then integrate those HANA native artifacts, like the calculation views, within the Cloud Application Programming Model and expose them as part of your OData service. Now, this tutorial has the major prerequisite that you've completed the previous steps in the tutorial series, and most specifically, that you've at least created your database artifacts, deployed them to the HANA database, and you've loaded some data into them. But also good if you've done the other exercises that include creating the Fiori UI and setting up security. That's what will be shown here in my experience. Now, with the SAP Cloud Application Programming Model and its implementation of core data services, we don't directly have an ability to import a calculation view or other HANA native database artifacts. What you do, however, is we can import, we have a way to basically expose these artifacts via OData v4 services, but we have to create a CDS proxy entity or a view on top of the other artifacts. Now, CDS syntax does have an annotation called @cds.persistence.exist. And this annotation allows you to basically define or redefine an existing database artifact. And CDS then won't attempt to create or alter it when you do a CDS build or deploy. It will just assume that that artifact already exists in the database and it matches the state of whatever you defined using CDS syntax. Now, this feature does require you to completely redefine the database artifact using exactly the same name and the same columns, the same data types, because CDS is just in the Cloud Application Programming Model is just going to make that assumption that whatever you tell it is what's going to match in the database. It's not going to do any checking. And it's not till runtime that there could be a conflict. So just be warned of that it can be problematic if you aren't careful and you mistype a name or you give it a different data type. You will not get any kind of warning or error as you build your project, as you deploy your project. It's not until you go to test it that you'll find those kinds of problems. Now, for more details on this topic in general, including other advanced features that we don't use in this tutorial, like adding parameters and using quoted names, you can refer to the online documentation, the CapFire documentation. It's got a whole section on this, including these other advanced techniques. Now, calculation views and other HANA native database artifacts do allow you to access HANA-specific features and other optimizations that you might not otherwise have available in the abstraction layers that come with the SAP Cloud Application Programming Model. So this can be very advantageous to mix in these HANA native artifacts alongside the rest of your CAP project and data model. Calculation views in particular are really good at aggregation and filtering of very large data sets, particularly when combining multiple tables together. So in this exercise, what we're going to do is we're going to create a fairly simple calculation view that just uses a join, and we're still based upon our very small sample data set that we loaded in here and the existing data model, but it'll let us see the mechanics, at least, of how you would create a calculation view and integrate it into your project. More likely, if you were actually using a calculation view, you would have a much larger data set and you'd be doing more aggregation and things with it. So don't be tripped up by our simplistic use case here. So let's start into our development. We'll go back to our existing project. And we're going to want to add some things to the database module here, where we have our interaction CDS with our main data model, but we're going to do this using HANA tooling now. So I'm going to come here and I'm going to use the command palette again. But this time I'm going to type HANA, and it's going to give me all the HANA specific commands. And I'm going to use the create SAP HANA database artifact, and this will start a wizard specific to HANA Native Artifacts. So very different than the way that we created our tables and views before. And what we're going to want to do is we're going to want to create a calculation view. Here you see all the different types of HANA Native artifacts that you can mix into your CAP project or use standalone from CAP as well. There's quite a few artifacts that can be developed and used. For this exercise, we're going to go ahead and do a calculation view, however, and we'll just give it a name. Interaction. Well, if I could spell. There we are. We'll keep the label the same, and we're going to do a dimensional type of calculation view and just keep it as a standard dimension. All right. The wizard will run, and we see a calculation view added to our DB source folder, and we see the calculation view editor starting to open. So I'll let that finish up opening, and actually I can get myself a little bit worse. I was going to try to give myself a little, there we are, give myself a little bit more screen space. It's the graphical editor. There we are. There we are. Give ourselves plenty of space to work here. Now, so what we have is the empty graphical calculation view editor. We want to add some tables to the initial join. Now, this is not that different than what we did logically in the CDS syntax with creating the composition. But we're going to do this in a graphical drag and drop manner and create a direct join instead of the abstracted syntax of the association and composition that CDS uses. So we're going to start here with a join node. Let's click on join, and we're going to add it to our layout area. And a join node expects you to add 2 or more data sources to it. So we're going to go ahead and we're going to add our existing database tables as our data sources. So we're going to start here with the header table. Oh, it's telling me I'm no longer logged into Cloud Foundry. Okay, so this is actually a good thing because this happens from time to time. I started doing the tutorials yesterday as I'm filming them. And remember, in the very first tutorial, when I first logged into Business Application Studio, I logged into Cloud Foundry. Well, that token only lasts for about a day, and they need to re-authenticate. And we need that connection to the HDI container to get us through the HANA database to use the calculation view editor. So I'm actually going to cancel out of this because I'm going to have to come back over here to Cloud Foundry. And see, it says log on required. So I'll just repeat those steps real quick that I used originally to log into Cloud Foundry. And we'll go ahead and sign in again. Connect to my organization, and my space is set. There we are. So now I've been signed into Cloud Foundry again. So let's try adding that data source here again. I don't think I have to refresh the editor. Yeah, it's picked it up. And what we want to add is we want to add the header table that we built and got deployed into HANA. And this is part of the reason why we want to do the hybrid testing with the with HANA, because we wouldn't be able to build this calculation view unless we were able to point to a HANA database and see the tables that we've already defined using CDS. If we hadn't deployed them actually to HANA, if we'd done local testing only and used SQLite, we wouldn't then be able to create a calculation view. So this is one of the major reasons to do this hybrid development approach. But let's go ahead and add our header table. And then let's repeat the process to add our item table. There we are, item table. Now they're both here and defined. I can make this bigger so you can actually see the header and item table. We've only defined the two, and now we need to set the join between them. So let me just put that there. And what we can do is we've got the ID column in the header, and that is joinable to the header ID column in the item. That's the key that they are joined on. And it automatically assumed a cardinality of n to many. I'm going to change that to 1 to many because we know that that's the case. For each header, there's 0 or more items, up to multiple, but only to 1 there. So we'll change that. Now we can decide which fields from the two tables do we want to surface up out of this join. So we want all the fields from the header table, but then from the item table, we don't need that key. It's just duplicate to the ID of the header table. But we do want to go ahead and grab the other 3 fields that are part of the item table and add them to our mapping. Okay, so let's define our join and the join criteria and the fields that we want coming out of our join. Now we want to expose that up to the next level. So we just grab the connector and we connect it up to the projection. And at the projection level, we have the ability to further refine which fields we want, or add in calculations or things like that. We're going to keep this really simple. We're going to do a straight projection of all the fields that are exposed by the join. And we can look at this at the semantic layer then. If you want to make further adjustments, add aggregations, add labels, things like that, you can. We're just going to go with the default. Like I said, we're keeping the calculation view part of this very simple. Mostly look at the integration mechanics that we have with the larger cloud application programming model. At this point, our view is done, and we're ready to go ahead and deploy this into the database. So just like we did before when we deployed the HANA database, we just used the rocket icon. So I will do that, and we see it connecting to the HANA database. There we are, and now it's deploying. And I'll roll this up because that was pretty fast. Just to show you here, it only picked up the changed files. It sent all the files in our project into the database. 18 files collected, 17 have been deployed. But the only ones that really saw were new or changed was the calculation view. And then it goes about deploying the calculation view into the database. So that's done now. That's good. Back to our terminal. Close that. And we probably want to go check on it, though. We can do that by going again to the Database Explorer. That'll open in another tab. There we go. Now, if we go under just regular views, we'll see the views that are created by CDS, but we will not see this calculation view. Calculation views are a different special type of view that are listed under column view. And that's where we're going to see our V interaction that was just created in the database by deploying it. And if we want to go ahead and test it, we can as well. We can do open data, and then we'll run a selection against it and return the data. We don't have a lot of aggregation or numeric data to do charting, but there's some built-in charting we can do here. We probably just want to go ahead and look at the raw data. And there we can see we've got some header data, we've got some item data. It's nicely combined. So we've seen the development of a calculation view within our CAP project, but now we really need to integrate that into the CAP portion of it. Nothing about CAP or the OData service knows anything about this calculation view yet, and that's what we want to do here in the next part. So what I need to do is I need to go to my CDS data model here, and I have to make a couple structural changes to it because I don't want and can't have this proxy entity for the calculation view having this namespace. Otherwise, the names won't match the underlying object. So what I need to do is I actually need to remove this namespace because that would automatically have it applied to everything in this file. And instead come here, right here, and create a context. A context is basically the same thing as a namespace in that it applies a name prefix to all the child objects, but a context allows us to do that to just a subset of our data model, whereas a namespace is automatically applied to the entire data model. And by doing this, now we'll still have the same name with app interactions added to the front of our header and item table and these data types. It's going to allow us to define this proxy entity for our calculation view without the namespace so that it matches the underlying calculation view within the database. Now, we could go about manually typing in the calculation view definition, but as I said earlier, it has to match exactly the names and the data types of the underlying database. And that could be error prone if you're going to manually retype all that. But there is a helper tool as part of the HANA CLI that will do most of that work for us. So let's go ahead and open a terminal. Let's make this a little bit bigger here. And I'm going to come here to the terminal. I'm going to use a HANA CLI command, HANA CLI. I'm going to tell it to inspect the view and then give it our view name, v interaction, and then give it an output type. Say output whatever you read about that view in CDS syntax. And that's going to go to the database and introspect the view that doesn't exist with a CDS representation, but take the SQL representation of the view and turn it into CDS. And if we want to see what it would look like here in its original SQL format, we can do that. There we see the actual SQL for that calculation view, but that's not what we need. For this exercise, we want to know the CDS syntax. So I'll just run that again. So it's performing the transformation on it. It changes the data types to be the CDS data types instead of the HANA native data types. Adds the CDS persistence annotations that we talked about earlier. So now we can just take that and I'll copy that and I'll add it into our CDS definition. There we are. Now it will be part of the CAP model. But because it has the persistence exist, there's nothing for it to generate into the database. So that annotation is going to allow us to redefine an existing database artifact, in this case our calculation view, and then CAP will just always assume that it exists in whatever state we defined. And because we had this tool generate the state and the data type and the names for us, we know everything's going to match up just right, and it should work perfectly. So I don't even need to redeploy to the database or anything like that because there's nothing to send into the database in this case. But we now also want to add it to our OData service. So let's go to the service definition and let's just import that as well. So we'll say using the interaction from the same file. There we are. And let's come here and let's add it after our items. Let's just create another entity here. But let's we know it's going to be read-only because it's a calculation view. It has to be read-only. So we'll let CDS know that. And then we'll say entity v interaction as projection on the interaction, the original source proxy entity. There we are. That's all good. Now, because I changed the service definition, though, we do have to run CDS build and redeploy that into the database because there are certain views that get created for any entity that's added to the service itself. Not that we have any changes for the calculation view proxy entity. But I'll just go ahead and deploy that in the database so all the views for the service will be there. And once that's done, I am able to go ahead and rerun my application. So here from the command line, I'm going to do a CDS watch profile hybrid. And it's starting up, but Now, if you did the exercises that add security to our service, if we come here and we try to run this, of course, the header is going to get unauthorized. But let's see what happens when I run the V interaction. It still works because we did not actually add any security definition to the calculation view. So this is kind of neat. It's even showing you how we can apply security to one of our entities, but not another. Maybe you want special security on the underlying tables themselves, but a view, a read-only view that sits on top of them, you could expose without authentication. And that's exactly what we've done here in this exercise. So we see that we're returning data from the calculation view, but it's coming through our OData service. So you have now successfully combined HANA Native Artifacts with the SAP Cloud Application Programming Model, and you've learned the modern HANA way to do that and still expose a calculation view via OData.